All right, for day 2 circles, we have to start off with this type of problem. We have the equation of a circle right there, x minus 2 squared plus y minus 2 squared equals 10. And all we want to do is verify that the point negative 1, 2 is on the outside of the circle, meaning it's on the arc of the circle. And since that's a point, the only thing we need to do is plug in negative 1 for x and 2 for y, and just see what we get. We want to make sure that we have equality. If we have equality, it means that it is on the arc of the circle. All right, so I filled it in, and then we just do order of operations on the left side of the equal sign as normal. And you get negative 3 because it's negative 1 minus 2, or plus the negative 2 squared. And then negative 1 squared equals 10. Keep on simplifying. Order of operations would say do exponents next. So 9 plus 1 equals 10, and obviously 10 equals 10. So yeah, we can say that the point negative 1, 2 is on the circle. It is one of the set of ordered pairs that is equidistant from the center of the circle, based on our definition of the circle. So this is kind of important because if we were to try a point that ends up being, let's say 12 on the left side, and we want it to be equal to 10, this basically means that this point, when we plugged it into this equation right there, it means that when we did order of operations and we got 12 on the left side and 10 on the right side still, obviously, 12 is bigger than 10. So that means that the point we plugged in on a circle, it's a pretty bad circle, but on the circle is somewhere out there. It's past the arc of the circle. It is not one of the points that is equidistant from the center, which is based on the definition of the circle. So if we plug in some point, any point, and we get like some number that is larger than the right side of the equation, it's on the outside of the circle. And similarly, if we plug in some number and let's say we get 8, that is less than 10. That means that the number we got, that point is somewhere on the inside of the circle, wherever it was. But it's not on the circle, and it's not on the outside, it's on the inside, because 8 is less than 10. So that's important for the next problem. Here it goes. So in this problem, there's a moving van that's 6 feet wide and 12 feet tall, and it's approaching a tunnel with a radius of 13 feet. So what that means for the tunnel, like if this were a complete circle, and we had the center, and if this were like a graph, the center of the tunnel is at 0, 0. We already know something about this equation that it could make if this were on a coordinate plane. So for part A, the circle equation, we know the radius already. So if the radius is 13, square that. We know that 169 goes in the right side of the equation for r squared. We also know that if we're talking about this thing as like the center of a graph, the middle of the tunnel then would be at the point 0, 0. If the point at 0, 0, we also learned yesterday that like it's just going to be x squared plus y squared. So the circle equation for this tunnel is just x squared plus y squared equals 169. Because the radius is 13, and the center is at 0, 0, which is what we're assuming, but we can do that. This looks like an owl, again, a red owl. So for part B, if the van is driving down the right lane, the only thing we really need to worry about in terms of like, is it going to make it through the tunnel, is if the closest part to the tunnel is going to be like slamming against it. So we need to know basically, if this point right here is going to be on the circle, which would also be scraping against it, outside the circle, which would be definitely not making it through the tunnel, or inside the circle, just like the last problem. If it's inside the circle, obviously this fan's going to make it, and it's not going to be a problem. So we basically just need to figure out what this point is, and if we can figure out that, we can test it in this equation and see if we have greater than, less than, or equal to. Again, if our point that we get from here is greater than 169, that means the edge of the van is way out here. If we get it less than, it means the edge of the van is in here. If we get it equal to, it means the edge of the van is right on it, which also probably wouldn't be good. So we just have to figure out what this point is, essentially, that point. So in order to do that, we know already that from 0, 0, the center, this van has a width of 6 feet. So from here to here is 6 feet. We also know that the height of the van, or it's right there, is 12 feet. And the van's not hovering, it obviously has really great wheels. So really we know that in the right distance it goes 6, and in the up distance it goes 12. So on a coordinate plane, that's just basically x is 6 and y is 12. So if we can plug that into our circle equation right there, we can determine if this point that's at 612 is going to be less than, greater than, or equal to 169. And then we know the implications about that. If it's greater than or equal to, it's not going to fit through the tunnel. If it's less than, yeah, it probably would be. The driver's good. So we got 6 squared plus 12 squared equals 169. And let's test it out. So we see that when we get 6 squared plus 12 squared, that's 36 plus 144, that's 180. And that is greater than 169. We know the van's not going to fit in there because this point is out here somewhere. If we try and get to the tunnel, it's going to slam against it. We're not getting anywhere. So we see that won't make it. The second part of the question is asking, well, what if you drove in the middle of the road down this tunnel in this van? Obviously, nobody's coming. You'd be all right. If someone's coming, it's not going to be good. So we're going to assume no one's coming down the road. It's the same radius. We know now that the van is the exact same dimensions, so we know that this is 6 feet. We know that this part is 12 feet. But what changed here is that since this is the center of the graph, and if we have this van being 6 feet wide, since it's driving in the center, only 3 feet of it is in the x direction. So now this is only 3. This part is still 12, but now we're talking a different dimension. If we go right 3 and up 12, that's our new ordered pair. So we'd have 3, 12. Again, that we're going to have to test against the equation x squared plus y squared equals 169, or 13 squared, because this is the same situation. The tunnel's the same, radius of 13, so it's going to be equal to 169. So we have the point 312. We can plug that in and see, essentially, if we're going to hit the wall of the tunnel or not. So this will be 3 squared plus 12 squared. And we say equals because that's the equation, but really that's what we're testing. We don't know if it's equal or not yet. So 9 plus 144 is questionably 169. and it's less because this is 153. So since it is less, we know that this point right here will not exceed the circle. It won't be out here. It won't be on the arc. It is less than it. It will be inside the circle, and so it will fit down the road. So this question, question number 12 on the homework, was a little tricky, but we can figure it out based on that. And this general template of the problem is the same as number 13. So give it a shot. Hey, good luck.